A vector is just some numbers. Sometimes we write them that way, like in C++. Sometimes we draw them as arrows. Sometimes we make them variables and we give them funny hats. Or maybe we say that they're dots and we have a line connecting the dot to the origin. But ultimately, a vector is just numbers that we could use as coordinates if we wanted to. The dimensionality is how many numbers there are. That could refer to space, but it doesn't have to. So hopefully you all already know this and you're rolling your eyes at how condescending I'm being. And I'm sure there's a bunch of math people who are raising their pitchforks at all the asterisks that I could have put on that statement. But by the end of this video, I'm hoping that you'll see vectors as just data. Let's say that we want to encode a color as a vector. So colors on computers have three components, your red, your green, your blue, and we can map those onto X, Y, and Z. And then just like that, we can visualize our colors in 3D coordinate space. Now, colors don't have an intrinsic position component. We've just assigned this based on their intrinsic properties. We can store these vectors in a vector database. Vector databases are different than your normal SQL table-style databases because they can do operations based on the hypothetical position of the items. So most data isn't going to map onto a vector as neatly as our color example did. But the idea is that as long as you can make a function that takes in data and outputs a vector in any dimensionality, that's called a vector embedding function. So let's make this a little bit more concrete. I'm going to go into Spotify. I'm going to search League, and let's go to everyone's favorite League song, and I'll do song radio. And now immediately, Spotify has given me this list of related songs. How did it do that? Surely it doesn't have every single song in a database and it's going through the entire database and checking, oh, is this song similar to God's? Is this song similar to God's? Because that would take forever. There's hundreds of millions of songs on Spotify, and that operation has to happen like that. So Spotify doesn't publicly disclose all of how their secret sauce works, but we can get some hints by looking at their GitHub. There's this project called Annoy, which stands for Approximate Nearest Neighbors. Oh yeah. And it can search for points in space that are close to a given query point. If we scroll down a bit more, we see we use it at Spotify for music recommendations. So based on that, we can be reasonably certain that whenever Spotify gets new songs, they're creating vector embeddings for those songs. And then when someone requests like a radio station or they want to give playlist recommendations or something, they take a song as a query point, and then they just find all the songs whose vector embeddings are near that point. So these top three songs actually worked out really well to what I wanted to demonstrate. We have Gods, of course, Heavy as a Crown by Linkin Park, and then Super Shy. So if I go to Super Shy radio, we're going to get nothing but K-pop. And then if I come to the Linkin Park song and do song radio, now we're going to kind of get the more like metal-y hard stuff. So off of those two songs, we kind of have two distinct clusters that must be close to League of Legends music because they came up in this radio, but they're kind of also distinct styles. So what might that look like in their vector embedding space? Well, we can say that this is Gods, and then maybe we say that this is Super Shy, and then this is Heavy as the Crown. And over here, you're going to have like all the K-poppy stuff. So like New Jeans, KDA, this is like your... And then over here, this is kind of like maybe the metal-y stuff. Other Linkin Park, 30 Seconds to Mars, Bring Me the Horizon. And also keep in mind that this is going to be in way more than 3 dimensions. I just have it in 3 dimensions so I can display it nicely in Blender. But the real Spotify vector system probably has thousands of dimensions. And this clustering that kind of encodes meaning and style is all going to be reliant on Spotify's vector embedding algorithm. And then lastly, before we move away from Spotify, it looks like they have a successor to Annoy called Voyager. I chose to use Annoy because I really like saying approximate nearest neighbors. Oh yeah. So the one I'm going to be using today for demos is Milvus. I picked Milvus because it has a REST API, so that's going to make it easy for us to directly interact with the database on the command line. Milvus's standard way of distributing the program is through Docker, and they've got these nice commands that we'll just be able to run and get it going. So I'll copy this, throw it in here, and then repeat for this one. It's going to download something from their website, and then we're going to run it. Looks like it's just a script that pulls their Docker image and launches it. Cool, so now it's running. So we'll start by creating a collection. And if you're familiar with normal SQL databases, you can think of a collection as kind of similar to a table. So let's take a look at their API documentation on how to make a collection. So here's the endpoint, and we're going to send a request to this endpoint using the curl command. So I'll do that. This is going to be a post request. We can see here it says post. And we're going to give it JSON data, which will be yucky in the terminal. So I'm going to open up VS Code. So what parameters do they want? We only have one database, so we don't need this. We are going to need this collection name. So let's start with that. Probably going to want number of dimensions. So metric type relates to how searches will be performed. The most intuitive one is L2, which without going into too much depth on the acronym, basically just means a normal distance search. Another notable one is cosine, which will search for vectors that have a similar angle and a similar direction as the query vector. But I'm just going to go with L2 for now. And then I'm going to use this auto ID thing so that we don't have to worry about assigning IDs to all our colors. All right, that should be it. Take that, come back to here, and I'm going to use data raw to give it raw data. Throw that in there, close the string. Oh, right. Need to actually give it a full URL. Let's try that. Cool. Code 0 means it was successful. Next, I'm going to list the collections to actually see that collection. Just be extra sure it went in correctly. Their endpoint for that is list, and it doesn't require any data. We get this response. It says data, colors. This is our one collection. And we can use the JQ tool to format it nicely. And then there's all this stuff coming from curl. You can get rid of that by using the -s flag to silence it. Nice. So now I'm actually going to add some vectors. Here's the endpoint for inserting stuff. And the two required parameters are collection name, which will be colors, and data, which will be the actual coordinates of the vector we want to insert. I'll spare you the pain of typing all that out manually, but the command is going to look like this. And this is going to insert a bright green. We have red, green, blue. Code 0, so that worked. And I've hooked this up to Blender so that we can actually see what we're doing. And now we can see we have this beautiful green dot right here at 0, 255, 0. Let's add a few more. Nice. Now let's say that we want to get all of the greenish colors that are in the database. We can just find all the stuff in this area. And we can do that using this search API path. The command is a little bit convoluted, but this is what it looks like. The thing that I want to highlight is this radius parameter. So radius is actually the radius squared. This 14,400 comes from 120 times 120. That's kind of, I want to search for everything within a radius of 120 on that 0 to 255 color scale. So if we run this command, collection not loaded. First time you use a collection, you need to load it and specify the collection name. Let's try that again. Great. So we got back 3 results. We got back 02550, which is just our query parameter. And that's going to correspond to this green right here. We got back 25555. So that's kind of like a bluish green. And that's probably going to be this one. And lastly, we got 100, 255, 0. So this has got a bit of red in it. This is going to be kind of a yellowish one. And that's this one. Milvus and other vector database programs can do this stuff really fast on millions or billions of data points over thousands of dimensions. And that's really useful for AI tools that use real data, like retrieval augmented generation systems. So to review, we learned that vectors are just numbers. We talked about how you can get any data into a vector by using a vector embedding algorithm. You can take these vectors and you can store them in vector databases. And that enables us to do operations like ranged search that are really useful for AI related stuff and for Spotify music recommendations. Don't forget to subscribe and destroy the like button. And thanks for watching.